Hello everyone, I hope you all are well and making progress in life. Here is Priyanshu and welcome to the Infinity Mind. So today I will be solving the problem remove nth node from end of the list. So the problem statement says that given the head of a linked list, remove the nth node from the end of the list and return its head. So basically we are just given a linked list and an integer n, and we have to just remove the nth node from the end of the linked list. In the example 1, n is 2 and this linked list is given. The head of the linked list is given and we have to remove the second node from the end, that is 4. So after removing 4 from the linked list, we will get the resultant linked list. This 4 is removed now and this 3 is directly pointing to 5. So now how can we do this? So first of all, brute force approach we can think of. If anyhow we reach here, we can say we can just directly point 3 to this 5. Alright, and now we if we keep track of this, let's say temp t, let's say temporary, and we can just delete this using delete keyword. So how to reach here? Because we are given that we have to remove nth node from the end. So what will be this if this node is second from the end? So what is this node from the starting? This is nothing but length minus n plus 1. Length of this linked list is 5 and n is given 2, and if we add 1, so this will be 4. So we can say that if we have to delete nth node from the end, it is length minus n plus 1th node from the starting. So we have to remove the 4th node from the starting. So we can just go to 3. If we have to remove 4, we can just go to 3 and point it to 5. And for that we have to, if we have to reach here 3, we have to get this length. So what we can do in first iteration, we can use a counter to keep the track of and to check, to count the length of this linked list. So first of all, going to check the length of the linked list, we have to traverse the entire linked list. So this will take big O of n time complexity. Then going to this length minus n plus 1th node, so this will again take at max it will take big O of n time complexity. Then we will just say that um, uh, point its next pointer to the next of the next. Alright, point 3 next pointer to 5. Alright, so this will be big O of 2n. Space complexity will be big O of 1, but time complexity will be big O of 2n, because we have to count length minus n plus 1 first. So what can be the optimal approach? How can we reduce this? So we have a special method also, slow and fast pointer. We can use that trick. So what's that trick? I will tell you. So we are given 1 2 3 4 5. 1 2 3 4 5. So if I choose a fast pointer in the starting, fast pointer is pointing to starting node, that is 1. Alright, this is fast pointer. I should write it correctly. Here is fast, and now n was given 2. So if we move this fast pointer on the linked list n times, 2 times, so first time it will be here, next time fast pointer will be here. Now using another pointer slow pointing to the starting, that is here, and now moving both the pointers fast and slow together by one jump, and till we reach the till fast pointer is reached to the end. So moving by 1, this will come here and this will go here. Again moving by 1, this will come here, this will go here. Now stop, because we have reached the end of the linked list. Fast pointer has reached the end of the linked list, end node of the linked list. So now the node where slow pointer will be standing, this will be the required node where we have to break the link. We can see n is equals to 2, we have to delete this node. So we have reached the slow node, so the next of the slow we have to remove. So what we can do now, we can just say next of slow will be fast, not fast, I'm sorry, not fast. Next of slow will be, I'm saying that slow of next is currently the node which we have to remove. So we can just break this link and say that slow of next will be pointing to directly slow of next of next. Alright, now this way this will be breaked, this 4 connection will be breaked, but we have to remove also. So we will just delete this also. We can just keep track of this deleting node, we can say temporary node. We can say that slows next will be our temporary, and we can just delete temporary node. So this hanging node 4 which is pointing to 5 will be deleted now. Now we will get directly 1 2 3, then 3 will be directly pointing to 5, and in between this will be deleted. So this was the logic using slow pointer and fast pointer. First what we did, we just moved fast pointer n times, and now use another slow pointer and keep moving slow and fast pointer simultaneously till our fast pointer will has reached the end. And once it has reached the end, we can see that slow pointer is standing at a node whose next is the required deleting node. Now we can just say that slow's next will be next of slow. This way we will skip this node, and we will just store it in a temporary variable node, and we will just delete this. So if I go and implement this, what I said, first of all we will use a fast pointer. So let's say I am going to say fast pointer will be nothing, initially it will be at head. Now we have to move fast pointer n times, so I will say that fast is equals to next of fast. Alright, now our fast will be somewhere after moving fast pointer n times. Now what if we suppose we have solved this. Alright, now what we will return, we have to return at last the return its head. We have to return the head of the linked list. So at last we will return the head. But what if the deleting node is our head? So what we will do in that case? So let's say n was given 5. If n was given 5, then we have to delete 1. So if we have to delete this 1, then how can we return head? So we will say that if fast pointer has reached the end, let's say fast point, if n was 5, this will be moving 5 times. So 1 2 3 4 5, and now fast pointer will be, if we see that fast pointer is a null, we can say that we have to delete the head. So now we can just directly return the next of head. We can directly return this. If we have to remove 1, we can directly return this head of next, that is 2. So that's why I will check a base case, edge case here, that suppose we are moving fast and fast pointer is now is a null pointer. Now we will say that we have to remove the head. In this case, head is removed. Alright, so we can just return the next of head. Alright, now in the else case, if any other node was to be removed, in that case we have to return the head only. So before returning head, we have to just code this logic here, that we have to just now use a slow pointer also. Now if I declare a slow pointer, this will be at head at the starting, and now I will keep moving slow and head fast, slow and fast pointers. So we will keep moving slow and fast pointers. So what I said, that we have to move slow and fast pointers. So for at if we move both, so which node will be reaching last node first? The fast pointer, because it is already ahead. So we can just keep track here of fast pointer, that while fast is not equal to null pointer, we will just keep moving fast and slow with the same speed, that is by one jump. Fast of next and slow will be slow of next. Next we can say that now slow will be at a point whose next we have to remove. So now we can say that next of slow is now not that node which we have to delete, it's we have to skip that. So next of slow will be next of slow. Alright, now we have to delete this also, so we have to keep track of that deleting node also. So before skipping this, we can just say that to delete, let's say to delete, this will be next of slow, and after relinking, now we can just delete this node, and at last we can just return head. Alright, now let's check the sample test cases first. So we are getting a runtime error. So why? Because slow is pointing to head at the start, and next of slow will be pointing to next of slow. So this is giving error. Why? We have done some error. So let's check. List node star fast is equals to head, and slow is also now pointing to head. So first of all, we declare a list node fast is equals to head, and we move fast pointer n times. And if fast pointer is null pointer, we can say we have to remove head, and now we will just simply return the next of the head. And now we declare a slow pointer which will be pointing to head now. And what can be the length? Length size can be, size is minimum 1, so we don't have any problem. So slow is equals to head. All right, now while fast is not null pointer, here we have done something wrong. I know that we have to reach we have to move slow and fast pointer until we reach the last node of, until the fast pointer is has reached the last node. So how we can check that this is the last node? If the next of this fast pointer is null pointer, this is the last node. So we can say if the next of the fast pointer is not null pointer, then we will move. So if I run this, so we can see that we have passed the sample test cases, and if I submit this, we will see that we have solved this problem successfully now. And now if I tell you the time and space complexity, so time complexity, we can see that this while loop is taking n, and we are just moving fast pointer and slow pointers. So at max these pointers will be traversing the whole linked list. So we can say that time complexity is nothing but big O of n, where n is the size of the linked list. And time complexity, we can say that if I check, are we using any space? No, we are not using any space. We are just deleting the node. So we can say that time complexity is big O of 1. Space complexity is big O of 1, and time complexity is big O of n, where n is the size of the linked list. Alright, so this was all about this problem. I hope you understood. Thanks for watching. Till then, keep learning and keep upgrading yourself. See you in the next video.